Good morning. This is fabulous to be in New Zealand. I love this country. I've been wanting to come here forever. It's such a beautiful place. Today we're going to have a conversation about a topic that's really on the lips of everyone around the world right now, artificial intelligence. It's a big topic, but let's see if we can make some context of it today. First of all, personally, it's an amazing time for me to be alive. I've been in this field 40 years. And I've seen a lot of the ups and downs of AI. I've never seen anything move this fast. It is just breathtaking. As Yuval Harari might say, technology is accelerating history, and AI is pushing us to warp speed. So today I'd like to offer you a little context to understand this rapid change, how we got here, where we might be going, and how AI might impact all of our worlds. Now, I think the modern AI story actually starts 30 years ago when the World Wide Web was created. Now, think back, do you remember what you had as your first experience of a web browser? Maybe many of you were in school. I was working at Stanford University as a researcher at the time. This is where the founders of Yahoo and Google, maybe you don't even know who Yahoo is, but Google you know, and they started their companies there at Stanford, and it was really heady times. People were like excited about the change. This is going to connect the whole world. It's going to be a completely different world after this. And it was clear that would be the case, and in fact, in retrospect, it did change the world. I mean, in some ways predictable, like e-commerce, and in some ways unpredictable, unforeseen, like the rise and dominance of social media. Well, today it's really there. 2/3 of the people on the planet Earth actually use the web. Now, the next chapter happened in 2007 when Apple launched the first iPhone and the era of mobile computing. It turns out that was also the year when a little startup called Siri started working on the first AI assistant for everyone. And by the time it was released by Apple in 2011, it was clear that conversational AI assistants would be part of everyday life. Think back, do you remember your first experience, sending a text with your voice, or asking Siri to look something up for you in the middle of a dinner conversation, or just to remind you to do something as soon as it occurs to you? Today, it seems like just part of how we use our phone. And in fact, Siri is used a lot by people all over the world, in more languages and more countries than any other chatbot like that. Now, just 2 years ago, technology is accelerating history, we saw the next major milestone, the launch of ChatGPT. And the latest generations from the other AI companies that are really, for me, a dream come true. Now, they really understand your intent this time, and they really know a lot. I mean, they have read most of the world's literature, and therefore have built on that bounty of the web that was started 30 years ago. Now think about what it felt like for you, because it was only 2 years ago when you first saw ChatGPT. It blew my mind, and I'm an AI guy. And today these chatbots are used by millions, hundreds of millions of people. Now, just a few more years from now, we may see, I think probably will see, general purpose artificial intelligence, or AGI. This is AI that's going to be as capable as most of us on most cognitive tasks, so a general purpose intelligence. And it's going to change all aspects of life, again, like the web, how we learn, work, socialize, and in this case, thrive as a species. So the cool thing is, you and I are going to see this in our lifetimes. We're going to experience this general purpose AI. So it's happening so fast, I think it's a good time to be alive, and it's a good time to be paying attention. So where are we right now? We're right in the middle of the wave. The technology wave is happening. It's transforming how we work and live. And the question for this morning is really this: will we be swamped by this tsunami, or will we learn to catch the wave for the ride of our lives? Well, to understand the difference between those two and understand where we might be going with this, I think it's helpful to understand this progression of how the modern AI got here to help you understand where it's going. So let's start with this story of Siri. As you know, I was one of the founders of Siri. Most people don't know it's actually a very small team, 24 people. Now, and also, we built the thing in 2 years. So how could something so big happen in just 2 years with a small team? Well, a lot of people think, wow, what is a great idea? It was the idea that did it. And I think the idea of a personal assistant was a good idea. You just sort of say what you want, and it does what you need to have done, like get a restaurant reservation or put a reminder. And the larger vision of Siri then and now is to create a universal interface to AI, a truly intelligent assistant. And that's going to help us do all the things we expect from an assistant. Now, what's interesting is that vision is powerful, but it wasn't the reason why Siri was successful when it was, because that idea had been around for a long time. In 1987, Apple put out a video called a Knowledge Navigator that showed what kind of looked like an AI assistant, like a Siri-like thing. This one had a face and a bow tie that talked to you in the corner of what looks like an iPad on what was envisioned as something that looks like the World Wide Web. This vision predicted all those technologies way ahead of its time. So we've had this vision in our collective heads for a while. The question is why in 2010, say, did we finally ship it? Well, it was a confluence of technology, talent, and timing, and it could have been done almost anywhere in the world. So let's talk about the three technologies that the Siri team noticed and jumped on when we had the opportunity. First, and it's easy to see in retrospect, but at the moment, the late 2007, we were at just the beginning of mobile computing. In fact, Google had still not figured out that when they put search on the mobile, it's going to outclipse search on the web. And soon, everyone's going to be living on these devices. But of course, if you've ever lived on a device like that, you don't get to use the old interface of mice and windows and keyboards to operate that little tiny screen. You need a new kind of interface. And so we realized this was the time to do the speaking virtual assistant. Second, let's not forget, there's technology in there. There was a stack of like 10 things from AI that we used. And the AI technology at the time is not today's tech, but it was the cutting edge, and we had to make a call. Was it good enough? And it was good enough for what we were trying to do. All the things you would try to do on restaurants and hotels and directions and all these things, it was good enough for that. The speech recognition was not good enough, but it was close. So this is where you take a risk as a startup. Could we start building it, betting that the puck's going to be over here if we skate to it in 2 years? In other words, the technology will be ready in 2 years that we can ship the thing that's going to be working for consumers. And it turned out that the bet paid off. Now, the third technology is very underappreciated, but relevant to companies like Spark, is that we were a little tiny startup that had ambition to serve 100 million users. How could we possibly do that? Well, we could put an interface on a little tiny phone. The first generation of the App Store had just come out. But we could put a cluster of many computers in the sky, in the cloud, and we have just enough bandwidth to reach the cloud. And then once we're in the cloud, those AI systems could call all the other services, like Google Maps and Yelp for restaurant reviews and all these other services, in milliseconds, and deliver a rich user experience down to the phone. And we called this big think and small screen. And we bet that if we could pull that off as we got more users, we could just add more servers in the cloud by pushing a button. And that's called Elastic Cloud, as you know, but it was a new thing back then. So we jumped on those three things. Basically, mobile computing, the AI technology of the time, and Elastic Cloud services. And this little tiny team could pull off Siri in 2 years. And a few weeks after we shipped it in the App Store, Steve Jobs gave us a call. And the rest was history. Now, the rest of history is worth exploring because it's not over yet. How did we get there? From Siri to ChatGPT, because they're a lot different. Well, two important things. First, in the mid-2010s, there's a technology called deep learning. You probably heard the phrase. It became the way you do AI 5 or 6 years after Siri was started. And how did this work? Basically, you give the machine lots and lots of examples of things like speech with the words that speech says, or images with the caption of what's in the image. It's called manual labeling. And then using very big, giant neural networks instead of little ones, that's why they call them deep, it could actually learn the task. And in fact, during this period of time, mid-2010s, The speech recognition in Siri and Google and Alexa all went from sort of not so good to pretty darn good in just a few years because of deep learning. And today we would say that under ideal audio conditions and everything, these machines are as good as humans at understanding speech. It was the labeled data and the deep learning that made it possible. The second thing you've probably never heard of is called transformer architecture. This was invented by Google in 2017. A transformer that was built by the people who do natural language understanding to transform from like English to French and so on. And they figured out a way so that the machine, when it's learning, doesn't have to be told the answer. It just said, here's the internet, go read the internet. And then in parallel, 1 million GPUs are humming away on that data. And if it plays a kind of solitaire with itself, it says, it's like putting cards down and saying, can I predict the next card in this game? All the cards are like words. And if you give it enough text and enough compute time, it figures out what all the words meant in the context of all those sentences and paragraphs and all that literature. And that's how they learn the smarts. That's how they get the AI models. And that would lead to essentially first universal translation and then ChatGPT. Now, as you know, these things are amazing. They are the modern UI to AI, user interface to big model AI in the cloud. And the AI models are the brains. They're in the cloud, and they have effectively learned, they're not trained to be smart. They learn from us. They learn from the collective works of humanity. And the result is a pretty clever little bot, right? These things are pretty smart. ChatGPT can take tests like nobody. I mean, it's amazing. It can take college entrance exams, graduate entrance exams. It can pass the test required to practice law in the United States on the first try. Most people take a few tries, even humans. Right? It's also a pretty good language translator. It speaks 120 languages, including the ones we could never get right at Siri, like the low-resource languages like Latvian or Welsh or Klingon, it turns out. And if you give these things something to read, as you know, you can give it something to read, and they can understand it as good as any college student. Now, the most important capability of these chatbots is language. Language is their superpower. And this has several implications. First, it means it's a universal interface. Anyone can use it. You don't have to be a programmer or a technical guy. This was the dream we had when we started Siri, a universal interface to technology. Secondly, because of their power with languages, the set of things they can do is very broad. Think about it. Anything that takes language as an input and language as an output is in range of automation. And that means the work of people like consultants and lawyers and ad agencies and marketing people. I mean, everybody, there's knowledge work in almost everyone's lives. And of course, today these can take inputs as in form of speech, in terms of images, even videos, and output in the same. So they're so amazing. What's their limitations? Well, they're really good at making things up. So if you want to make things up to help creative flow or something, they're fabulous. But they're also really equally good at confabulating things out of thin air. And this is called hallucination. And it's an unsolved problem with these models, unsolved. Remember that quote at the beginning of the talk? It was from Yuval Harari. I asked an AI chatbot for a quote. So give me something with technology and celebrating history and so on. And it happily gave me a quote. It said, here's a popular quote by Yuval Harari. I said, okay, great. What book is it in and what page? And it's like, I can't find it. In fact, I got the books in Kindle and searched them. It's not in there. He never said that. The machine has no way of knowing the difference between reality and fiction. It has zero way to think about it. I told it, it knows what the word quote means. It put quote marks around it. It said, Yuval said this. With a smile, like it doesn't care. It doesn't know. It's not lying, it just doesn't know the difference. Hallucination isn't a bug. The programmers aren't going to go find the bug and fix it. It's inherent in the way these systems work today. And it doesn't matter if they keep getting bigger and bigger. They're going to hallucinate. Now, that's what if you see these things passing IQ tests, and they are, because written IQ tests are bounded things that these things can pass. But I don't call them geniuses. And the reason is they're only good at one very important thing, They're language savants. Right? They do not know what they're talking about, and they can talk, but they do not form sentences based on looking things up or understanding the world. What this means is under the very best of conditions, when everyone's trying to get to the truth, they still make things up, and they cannot reflect on whether it's true or not. Now, if you take this ability to make things up, and you use it deliberately to create fiction, right? You can use it to augment your creativity. It's like make mock-ups and prototypes and role play with you, and maybe even help you write that boring email reply, because who cares if that's fiction or not, right? But you can also use it to make deep fakes. And these fakes are fake language, fake image, fake videos, fake voices, fake faces, fake people. These fake people that any 14-year-old kid can download and do today are indistinguishable by panels of humans from the real thing. Now, the disturbing side of this technology is that means that the same technology can help us make pretty pictures, can also make fake news and other kinds of false and misleading, meaning really truly false and misleading content. It's no longer technically difficult for an amateur, not a highly trained hacker, an amateur, to start a rumor on social media to drive the price of a stock, or to create an ad for a product endorsed by Elon Musk, a fake Elon Musk, or to put words in opponents, and so on, or, and this is a good one, this is true, convince people to wire $25 million because you saw the CFO in a Zoom call tell you to do it. All fake. These are unintended consequences of technology. And again, as I say, as an expert in this field, I'm telling you, it's inherent in the technology, so buyer beware. But don't worry, I'm not going to go down this dystopian rabbit hole in today's talk. It's too early in the morning for that. But it's not surprising. Powerful technology, whether nuclear power, all kinds of technologies, can be used for good and evil. All it means for us, though, is that we just need to be thoughtful about when and where and how we apply it and what to expect when we do apply it. So really, how do we wrestle with this sort of ethical problem of AI? How do we decide when and how to harness the technology so it produces the consequences we intend and not the unintended consequences we want to avoid? Well, when I think about these questions, I use a concept called humanistic AI. Now, humanistic AI makes a distinction between AI that's designed to compete with humans by automating the things they do, and AI is designed to meet human needs by augmenting and collaborating with them. It's best seen in some examples here. So the UI for automation makes sense when we're trying to automate tasks where machines are clearly better than humans at the task, better suited, such as dangerous factory floor automation, where you want robots down there with the sparks flying, you don't want humans down there. And, well, augmentation makes sense when we want to help people do something we're already trying to do, like eyeglasses. Eyeglasses augment our vision, as do microscopes and telescopes. They help us do what we're trying to do, but just better. Now, it turns out that if you, in general, choose AI projects that automate, it tends to lead to competition with humans. And if we choose AI products that augment, it tends to lead to collaboration with humans. Now, both goals have their merits, but I've just found for myself humanistic AI is a choice. I go down the humanistic side when deciding what projects to do, what companies to invest in, which things to advise, and really how to help steer the conversation about what the world should do. Now, a great example of AI's augmentation is a company called Cognition. They make a device that helps severely disabled people who can't speak because they have a condition like ALS or cerebral palsy. Well, they're in trouble. They're locked in. They can't speak. Now, it helps them speak using their brain. It's an augmented reality headset. Imagine a headset over your face like this. It's a wearable consumer thing that, well, it has a heads-up display, and it reads brain signals from the back of the head. And the AI listens to the conversation that's going on between this person and the other person, and offers things that the user might say in response to what the other person is saying, using that language model technology, and then interprets the brain signals to say which of the things on the screen that the user is thinking about. They're mousing with their brain. And then they can speak out the words in a speech synthesizer. So in a sense, the AI is augmenting the user by extending their brain the way eyeglasses extend the eye. It's very cool. Now, AI can also extend our ability to think collectively. So if you think about collective intelligence, science is one of the best examples of this. And there's an example of a project that Google DeepMind did, accelerating the basic science of biology. Now, one of the things that biologists think about a lot is how proteins fold. It's called a protein folding problem. It's determining how, when the amino acids come out, they get folded up into a three-dimensional structure, that's shape, and that structure, that shape, is what determines the function in living organisms. Now, conventionally, they would take months in a laboratory with X-rays and all kinds of fancy equipment to figure out the structure of a single protein. And there are hundreds of thousands of them that were unknown. So the Google team created an AI program called AlphaFold that can solve this problem. It takes the input, the amino acid sequence or the genome, and it can compute that three-dimensional structure. And then they turned it on all the proteins known to science and solved it and gave it away to the world. This has already begun to accelerate basic life sciences and drug discovery. And just last month, they won the Nobel Prize for this work. So AI is already augmenting our ability to think collectively. And AI can also be thought of as a collaborator. Hi, Siri is an example. Well, it's not Nobel Prize material, but we thought of them as humanistic AI. We thought of them as an assistant, a personal assistant, in the role of a collaborator. Just like if you had an executive assistant on the phone, it would be like Siri. Now, it doesn't replace real assistants, because almost nobody who has Siri has a real assistant. It didn't put those people out of jobs. And plus, Siri can't go get your dry cleaning either, so, there's always a role. But it essentially augments us to use our technology more effectively when we're on the go. Now, in today's practice, you see already assistants being used as teammates. You might have noticed that little annoying thing in the corner of your Zoom screen or Google Meet or whatever. Who is that guy? Who invited that? Well, it was actually a bot. They invited an AI bot that's actually acting like a secretary in the meeting, taking notes and so on. And that's a kind of collaboration, and we're going to see more and more of that. Now, using this lens of humanistic AI, collaboration versus competition, augmentation versus automation, I'm going to look at some of the ways that AI is transforming some of the industries we see today. So let's start with software engineering. Programmers are early adopters of tech, and they love AI. Today, it's used routinely already in software engineering. Now, what's interesting, though, it's a good window into what the near future is going to look like for all of us as AI comes into our workplace. Because the programmers who have learned to adapt and put to use the latest AI tools are the better programmers. They were the better programmers to start with, and now they're even better than everyone else. So think about, they're the ones that will get the raises and the bonuses and the job opportunities as AI comes in. And it's also allowing them to be more productive, but more importantly, it allows them to offload to the machine routine and kind of annoying things like writing tests and doing functional checking and all this busy work. That's part of software engineering. And so what's going to happen for you and me is maybe our software quality will go up a bit because the software will be more written by more well-tested software. And also, it might let people who aren't programmers at all, maybe like us, maybe we want to build a little spreadsheet with a model in it to analyze something, or maybe we want to build a website that's interactive. We no longer have to hire a programmer because these AIs can do simple programming tasks like that. Now, another example is creative services. Now, I think there's a lot of creative services here with the film industry and so on. If you make commercial images for a living at all, or write text for a marketing department, or use the content, if you have to feed the social media beast every day with new stuff, you're probably already using generative AI tools. And the transformation of this industry isn't just about like the little shortcuts to make costs go down or what have you. The skilled workers in creative services industries are essentially changing their roles from lots of like building pictures to strategic and creation work. Automating basically the stuff, again, it could be fun to make pictures, but the creative and the more mental things, the more human things are now more valued. So, for example, normally, like marketing services, creative services, there'll be the person, say, drawing the thing, and the person who's kind of paying for the work, and there's this constant conversation. This is the comp, did you like that one? I know I want it in orange, loop, loop, loop. And the rate at which that conversation can happen is determined by the productivity of the generative piece, okay? Well, that's changing. And I'll give you an example. This talk, you've seen a lot of pretty pictures. Almost every picture in this talk was done using generative AI. And my designer and I actually used the AI as a third partner. And you see the motif of the wooden puppet to represent the AI. Well, that came out of several hours of conversations we had, both with written and in visual generative AI, to come up with various ideas until we went the aha moment. And then we refined that moment to produce this theme that we could reproduce and over. This is unbelievable. First of all, it did things that neither of us would have done. So it basically stepped up our level of performance and productivity and creativity, but also it just made it a lot more fun, because we could try 100 ideas where we could only previously try one idea. So there's just a couple of pictures of how already industries are changing. Now let's look at maybe the whole workforce, because a lot of you are responsible for workforces. Well, let's think about how to ride this wave, because we don't want to be hit by a tsunami, but we have to be aware of what's happening. And again, let's put on this lens of augmentation versus automation. Now, in some cases, AI is going to automate jobs. There's no way around this. So I thought about it a little bit, and I think, well, there's three situations where the most profound job automation is going to happen. It's where existing needs are not met terribly well, human labor is a limiting resource, and the service that's provided is fungible, that is, can be replaced by other workers easily. Guess what? Call centers is such an example. I understand there's an industry here in call centers. Now, the thing is the market well served? I don't know, but when I have to call a call center, I'm not usually in a happy mood about it, because it's just not a service that's usually too slow, often there's language barriers and so on. But anyway, for whatever reasons, it's not like it's a stellar job that the best humans are paid highly for, right? Secondly, well, the human labor is available, but it's not happy labor, especially the entry level, and it's one of the highest churn rates of any employment category. And thirdly, yeah, it's fungible. The level one people answering the phone are just trained in a week or two, and then they're off to the running. Well, guess what? That level one entry job is going to be automated by AI. But maybe the level 3 jobs aren't, because they become more strategically valuable to handle the cases that the AI really can't or shouldn't be allowed to do. So that's job automation, and that's how it might look in your industries. Job augmentation is going to be more common in the next 5 or 10 years. Job augmentation means, well, basically there's a split of work in the workplace. The same human's going to do some jobs that are going to be handed off to the AI, and some will be kept for the humans. So example of this is marketing services. If you build advertisement, for instance, for a client, you're going to see that the life cycle of the advertisement is going to be highly optimized and streamlined, so that there'll be huge, like machine gun content generation of content for advertisement. It'll be rapidly tested and deployed and iterated, and that's going to be highly automated. But humans will still be necessary and valued for doing things like analyzing markets or communicating with clients or deciding on strategies or executing with partners. Why? Because humans have a better model of these markets and clients and partners, because they're comprised of other humans. Now, it's not guaranteed that AIs can't get better at that task, but in the near future, I think that's how it's going to fall out. Now, there are so many great applications of AI on the horizon. I don't have time to go into the ones I'd love to share with you. But I think we could be part of the choice of which applications to invest in general. And if we start with this philosophy that AI is there to serve humanity, to serve human benefit, it means that we should look at those applications that address some of the big unsolved problems of humanity. Now, these include using AI to accelerate scientific progress, like we saw with the AlphaFold program. Also, in material sciences, we need new materials to build batteries and superconductors, and technologies to deal with climate change. And we could use superhuman intelligence to move us forward as a species on these big, important problems. And by the way, all three of those efforts are heavily underway. And they also include AI to do things that humans currently do, but there aren't enough humans to do them, such as personalized tutoring and mental health care. Now, personalized tutoring is a really big opportunity here. If you give a student a personal tutor, they get at least one standard deviation or one sigma better as a learner than people who don't have a tutor. And that's across all kinds of ages and stuff. So if we gave every child in the world a personal tutor, an AI personal tutor, imagine the impact we could have on inequality and opportunity around the world. It would be a leveling effect on the entire new generation of people. And mental health care, the World Health Organization says 1 billion with a B people are in serious need of mental health care. This is not including all the mess that COVID has done to our heads. And yet, you think there's 1 billion psychiatrists out there? There's no way humans can meet this need. But there are forms of conversational therapy that are being experimented with conversational AI tools that it looks like we'll be able to do a lot of good in this space. And these ambitions are actually now within reach with AI. I'm going to conclude with something that's kind of obvious in hindsight, but I think that makes it even more interesting. What is this AI stuff anyway? Is it like diamonds? Is it like gold? Is it like rays of light from the sky? No, it's just bits. Right? What does that mean? Well, once it's created, even if it cost unbelievable amounts of money to create the foundation model, and only 5 companies on Earth have the talent and the GPUs and the money to create those foundation models, it can be relatively cheap to deliver the application to the end user. Because applications like AI applications can be like the big think small screen. They can live in the cloud and have really, really lightweight interfaces at the endpoint. And that means they can be distributed anywhere within reach of the web and cell phones, which is reaching over 2/3 of people on the planet, and increasingly most of the people on the planet. And secondly, because of the superpower with language, AI's medium is speaking on your terms in your language, which means that even if you're technically illiterate or even poorly educated, you can still use this tool. You can use the cutting edge of all of technology. And third, because of the heavy lifting, like the big foundation models that cost billions to make, are really solving 80–90% of the problem of an intelligent application. The top, the cream part, can be built by new companies arising in countries like New Zealand that build on the foundations to solve a specific business problem. And that's where we're on now. That means we can harness human ingenuity and entrepreneurship and inventiveness and a motivation to do something cool with a small team for the big audience. And that means we can start to address these problems that have been on the shelf for too long, like mental health care and education. They've been sitting there waiting to be solved, but we haven't had the technology to do it at scale before. In short, we now have the potential to bring the benefits of the most transformative technology in the history of the world to every person on Earth. And that makes me very optimistic. Thank you very much.
Thank you so much, Tom. Take a breath, take a drink. If you have a question for Tom, please do get it in via the app. We've had heaps so far. I wondered if I could just first kick off by asking, What is the business case for humanistic AI versus simply automating and replacing these troublesome humans that need breaks and healthcare and benefits? Because I guess as much as we might like to think that a humanistic way is the way forward, business tends to do what drives the best return on investment.
Yes.
So what's the business case for doing it in the augment rather than the automation route?
Well, I mean, there's going to be business cases for eliminating labor, like in some portion of the call center, for instance. But really, if you think about if businesses employ humans at all, humans are the valuable, rare resource. They have the most leverage to improve their productivity. So if you wanted to improve the productivity of your business, improving the productivity of the people you have, equipping them with power tools that can let them do things, that's a good business case. The other thing is this: if you want to thrive in the future world and build a business where people want to come to your work and are really happy to work for you and work hard for you, you're going to be better off as a business if their interests are aligned with your business's interests. And those companies that have thrived in that space, they call it double bottom line accounting, accounting for both the employees and the impact on society, outperform the ones that only optimize for profits in many, many cases.
There's actually a really good question here, I guess, about skills. If, in the example you gave around the call center, if we eliminate the tier one, entry-level jobs, and that's automated, and so there's new jobs in the 2, 3 top-tier sections, how do you gain the skills to get up there if you never gain the skills when you first step in the door?
Yeah, that's a great question. But it turns out learning skills is now easier than it's ever been because of AI. If an AI can do the job, it can also teach the job. Right? You can practice in a simulated environment. The AI can pretend to be a caller. The AI can pretend to be your boss. It can pretend to be all these roles. So actually, we can turbocharge the upskilling using AI.
You talked about AI not knowing what's true and what's not true. There's a question from Richard. How do engineers identify and overcome the hallucinations in AI-generated software code?
Yeah, so one thing is you don't just put a thin, a bow on top of ChatGPT and say that's your product. That's exactly what causes this problem. But if you use these language models and these foundation models as sort of a task and put it in a box, so your job now is to analyze the text and summarize. Your job is to extract, and then you tell it just do that one task, and then you orchestrate those tasks. It's called an agent approach. That's one way that people are doing that. The other thing is, you don't have to expose the full, let the machine make something crazy and give it right to your end user. You can mediate what the machine gives you as who own the application, and then you can make sure that you're filtering before you send it to the end user.
If it doesn't know what's true and what's not true, what are the risks in setting it loose in tutoring our kids or helping them with their mental health?
No, you're absolutely right. There are also risks there. And so now when we say helping a kid with the mental health, it's going to be implementing cognitive behavior therapy or some other procedural, algorithmic type therapy. And you can say, is this conversation going off the rails? You don't let it say, let's talk about Jungian archetypes and the dark side of humanity. You just don't let it go there.
Yeah, because that philosophical discussion can end up down a rabbit hole.
Yeah.
It does raise a good question here from Ben. Who should be responsible for putting in checks and balances on how far AI is used? Is it the responsibility of business, or is it down to governments? Something else?
I think it's both at different levels. I mean, the governments need to step up, and the EU and even Australia are leading in that. We don't have to invent that. There are government ideas there about how to put governance around the application layer. Like if it's critical infrastructure, you have to be super careful of what things you let this AI do, and so on. But even business, the way the businesses are responsible, I think, of harms done by letting something loose in the world. So that's where the choice of which application to do. That's why you wouldn't just say, here's ChatGPT with a Band-Aid, go have fun with it. Let's make sure that it's if it's customer support, make sure the thing is bounded very carefully to just talk about products here. Thank you very much. Right?
Simon has a question. What are the privacy guardrails that you encourage business to think about when deploying AI, particularly when we think about large government and enterprise customers? How do you find the balance between the potential safety benefits of things like, say, facial recognition, which I know supermarkets in New Zealand, for example, are trialling, with the views of those that want to, I think this is the Chaos Computer Club, which is advocating for the right to reclaim our faces.
Yeah. Privacy is something near and dear to me. It's a long conversation, but there are technologies today to be able to build large machine learned models without sharing data. And they exist, and I can tell you about it later. There's no excuse not to do that if you have a requirement or a need to keep the data separate. So you can build a big face recognition model, for instance, without sharing everyone's faces, or medical records, or whatever. The second thing is also the contract with the customer needs to be understood. People need to know, what are they giving up? So you go to the airport, and most airports have these face things now, but they often say the data is erased after we do the match. And that's clarity of disclosing or revealing what you're going to do with the data, and that's a good policy to help with this.
You mentioned, most people have access to a mobile device, and even if they're not particularly technology literate or even literate, that they can potentially use these tools. But how do you see the adoption of AI tools around the world? Presumably, this is not an even pace going on in different jurisdictions.
It may not be, but remember, it's not expensive. I mean, it's kind of expensive today, but we expect it'll be cheap enough in the future where it'll be like having a web page to have an AI access for specific applications. So educational tutor or something like that. It could be subsidized by a government, whatever, to be effectively free to a population. So I don't think there's going to be inequality in who gets access to it. But in terms of who's going to actually adopt it first, well, right now, the early adopters are the technically most sophisticated people, or people who have burning problems in productivity that just want to solve them right away, and they're jumping on. But really, it'll be the business leaders like you. You're now making those decisions that are going to affect us in the next 5 or 10 years. Which applications are you going to do in your company using AI? And by the way, you don't have to use large language model AI. Most AI out there just uses deep learning and labeled data training.
You talked about the warp speed that we're currently moving at. There's a question here from Alan. Do you think that the custom models being built today for somewhat simple tasks will be redundant too quickly to be a valuable investment?
That's a really good question. If you're spending a lot on a custom LLM, stop spending a lot on it. Someone else will spend it for you. I think we can build on other people's foundations relatively economically. But if you're fine-tuning a model, which is not the same as building it from scratch, that's going to be a process where we're going to have to refresh that constantly, just like we refresh software releases. And that's not really inherently uneconomical. That can be done relatively feasibly.
You talked about the images in your presentation and how you worked with the designer and AI. Ben would like to, no, not Ben, Dewa would like to know, how do you view AI's role in creative fields like art or music? Can machines truly be creative, or is it just mimicking human creativity?
I think creativity is usually a conversation, in my experience. Sometimes it's a conversation with yourself, but these things are great at creative conversations. And it depends how you define it, but I have a painting by an AI system from the 1980s. That's a giant thing that robotically painted things. That's creative. It makes things novel and interesting every single time it paints it. And then today you can go to Midjourney and make things that look creative. The most important thing is, why are you doing the creativity? So for example, in this realm of music, I have this AI and music company. We decided that for Humanistic AI, approach to that is, don't automate musicians. No, there's plenty of them and people love it, and there's no need to automate them. But give them tools so that if they like to write music, you can expand how that music is delivered and make it adapt, for instance, to new things. So that is a way that you can see creativity is enhanced. Just like my creativity, I'm a photographer, not a drawer. I know when I see it whether I like it, like this image of these people up there. Oh, it's not there anymore. I was trying to show people surrounding a language model. Well, it was a very complicated, abstract idea. It took a while to get there, and it's 1,000 fake people on one screen. And yet, once I got close to it, I could tell the AI how to get closer and closer. I would have never have thought from blank sheet to use that kind of an image. So it's really a creative partner for me.
Well, we are lucky enough to be hearing more from Tom Gruber a little bit later, but for now, please, huge round of applause, Tom Gruber.
Thank you very much. Thanks.